This is a photo of M and MS piled together. The M and MS are red, blue, green, yellow, orange, and brown. Figure 8. 1. Have you ever wondered what the average number of M and MS in a bag at the grocery store is? You can use confidence intervals to answer this question. Credit. Modification of work sweet, orange, food, green, red, color, brown, blue, colorful, yellow, chocolate, snack, dessert, toy, plain, candy, sweetness, treat, confectionery, coated, MMS, hard shell, snack food, jelly bean. /px here, public domain chapter objectives. By the end of this chapter, the student should be able to calculate and interpret confidence intervals for estimating a population mean and a population proportion. Interpret the student's t-probability distribution as the sample size changes. Discriminate between problems applying the normal and the student's t-distributions. Calculate the sample size required to estimate a population mean and a population proportion given a desired confidence level and margin of error. Suppose you were trying to determine the mean rent of a two-bedroom apartment in your town. You might look in the classified section of the newspaper, write down several rents listed, and average them together. You would have obtained a point estimate of the true mean. If you are trying to determine the percentage of times you make a basket when shooting a basketball, you might count the number of shots you make and divide that by the number of shots you attempted. In this case, you would have obtained a point estimate for the true proportion. We use sample data to make generalizations about an unknown population. This part of statistics is called inferential statistics. The sample data help us to make an estimate of a population parameter. We realize that the point estimate is most likely not the exact value of the population parameter, but close to it. After calculating point estimates, we construct interval estimates, called confidence intervals. In this chapter, you will learn to construct and interpret confidence intervals. You will also learn a new distribution, the student's t, and how it is used with these intervals. Throughout the chapter, it is important to keep in mind that the confidence interval is a random variable. It is the population parameter that is fixed. If you worked in the marketing department of an entertainment company, you might be interested in the mean number of songs a consumer downloads a month from Apple Music. If so, you could conduct a survey and calculate the sample mean, letter 1D465, and the sample standard deviation. You would use letter 1D465 to estimate the population mean, and S to estimate the population standard deviation. The sample mean, letter 1D465, is the point estimate for the population mean mu. The sample standard deviation, S, is the point estimate for the population standard deviation, sigma. Each of letter 1D465 and S is called a statistic. A confidence interval is another type of estimate, but instead of being just one number, it is an interval of numbers. It provides a range of reasonable values in which we expect the population parameter to fall. There is no guarantee that a given confidence interval does capture the parameter, but there is a predictable probability of success. Suppose, for the Apple Music example, we do not know the population mean mu, but we do know that the population standard deviation is sigma equals 1, and our sample size is 100. Then, by the central limit theorem, the standard deviation for the sample mean is letter 1D70 letter 1D45b square equals 1100 square equals 0. 1. The empirical rule, which applies to bell-shaped distributions, says that in approximately 95% of the samples, the sample mean, letter 1D465, will be within two standard deviations of the population mean mu. For our Apple Music example, two standard deviations is 2, 0. 1 equals 0, 2, the sample mean letter 1D465 is likely to be within 0, 2 units of mu. Because letter 1D465 is within 0, 2 units of mu, which is unknown, then mu is likely to be within 0, 2 units of letter 1D465 in 95% of the samples. The population mean mu is contained in an interval whose lower number is calculated by taking the sample mean and subtracting two standard deviations, 2, 0, 1, and whose upper number is calculated by taking the sample mean and adding two standard deviations. In other words, mu is between letter 1d465 minus 0, 2 and letter 1d465 plus 0, 2 in 95% of all the samples. For the Apple Music example, suppose that a sample produced a sample mean letter 1d465 equals 2. Then the unknown population mean mu is between letter 1d465 minus 0, 2 equals 2 minus 0, 2 equals 1, 8 and letter 1d465 plus 0, 2 equals 2 plus 0, 2 equals 2. 2. We say that we are 95% confident that the unknown population mean number of songs downloaded from Apple Music per month is between 1, 8 and 2, 2. The 95% confidence interval is 1, 8, 2, 2. The 95% confidence interval implies two possibilities. Either the interval 1, 8, 2, 2 contains the true mean mu, or our sample produced in letter 1d465 that is not within 0, 2 units of the true mean mu. The first possibility happens for 95% of well-chosen samples. It is important to remember that the second possibility happens for 5% of samples, even though correct procedures are followed. Remember that a confidence interval is created for an unknown population parameter like the population mean, mu. Confidence intervals for some parameters have the form point estimate margin of error, point estimate plus margin of error. The margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. When you read newspapers and journals, some reports will use the phrase margin of error. Other reports will not use that phrase, but include a confidence interval as the point estimate plus or minus the margin of error. These are two ways of expressing the same concept. Note, although the text only covers symmetrical confidence intervals, there are non-symmetrical confidence intervals, for example, a confidence interval for the standard deviation. Collaborative exercise: have your instructor record the number of meals each student in your class eats out in a week. Assume that the standard deviation is known to be 3 meals. Construct an approximate 95% confidence interval for the true mean number of meals students eat out each week. Calculate the sample mean. Let sigma equals 3 and n equals the number of students surveyed. Construct the interval letter 1d465 minus 2 sigma square root, letter 1d465 plus 2 sigma square root. We say we are approximately 95% confident that the true mean number of meals that students eat out in a week is between and. A confidence interval for a population mean, when the population standard deviation is known, is based on the conclusion of the central limit theorem that the sampling distribution of the sample means follow an approximately normal distribution. Suppose that our sample has a mean of letter 1d465 equals 10, and we have constructed the 90% confidence interval, 5, 15, where EBM equals 5. Calculating the confidence interval to construct a confidence interval for a single unknown population mean mu, where the population standard deviation is known. We need letter 1d465 as an estimate for mu, and we need the margin of error. Here, the margin of error, EBM, is called the error bound for a population mean, abbreviated EBM. The sample mean letter 1d465 is the point estimate of the unknown population mean mu. The confidence interval estimate will have the form point estimate error bound, point estimate plus error bound, or, in symbols, letter 1d465, letter 1d438, letter 1d435, letter 1d440. Letter 1d465 plus letter 1d438, letter 1d435, letter 1d440. The margin of error, EBM, depends on the confidence level, abbreviated CL. The confidence level is often considered the probability that the calculated confidence interval estimate will contain the true population parameter. However, it is more accurate to state that the confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken. Most often, it is the choice of the person constructing the confidence interval to choose a confidence level of 90% or higher, because that person wants to be reasonably certain of their conclusions. There is another probability called alpha. Alpha is related to the confidence level, CL. Alpha is the probability that the interval does not contain the unknown population parameter. Mathematically, alpha plus CL equals 1. Example 8. Suppose we have collected data from a sample. We know the sample mean, but we do not know the mean for the entire population. The sample mean is 7, and the error bound for the mean is 25. Letter 1D465 equals 7, and EBM equals 25. The confidence interval is 725, 7 plus 25, and calculating the values gives 4595. If the confidence level CL is 95%, then we say that we estimate with 95% confidence that the true value of the population mean is between 45 and 95. Try it 8. Suppose we have data from a sample. The sample mean is 15, and the error bound for the mean is 32. What is the confidence interval estimate for the population mean? A confidence interval for a population mean with a known standard deviation is based on the fact that the sample means follow an approximately normal distribution. Suppose that our sample has a mean of letter 1D465 equals 10, and we have constructed the 90% confidence interval, 5, 15, where EBM equals 5. To get a 90% confidence interval, we must include the central 90% of the probability of the normal distribution. If we include the central 90%, we leave out a total of alpha equals 10% in both tails, or 5% in each tail, of the normal distribution. This is a normal distribution curve. The peak of the curve coincides with the point 10 on the horizontal axis. The points 5 and 15 are labeled on the axis. Vertical lines are drawn from these points to the curve, and the region between the lines is shaded. The shaded region has area equal to 0.90. Figure 8. 2 letter 1D707 equals letter 1D44B plus or minus letter 1D440 letter 1D6FC. Letter 1D70 letter 1D45B square root equals 2 plus or minus 1. 96, 0. 1 equals 2 plus or minus 0. 1961. 804 less or equal to letter 1D707 less or equal to 2. 196 to capture the central 90%, we must go out 1. 645 standard deviations on either side of the calculated sample mean. The value 1. 645 is the z-score from a standard normal probability distribution that puts an area of 0. 90 in the center, an area of 0. 5 in the far left tail, and an area of 0. 5 in the far right tail. It is important that the standard deviation used must be appropriate for the parameter we are estimating. So in this section, we need to use the standard deviation that applies to sample means, which is letter 1D70 letter 1D45B square root. The fraction letter 1D70 letter 1D45B square root is commonly called the standard error of the mean, in order to distinguish clearly the standard deviation for a mean from the population standard deviation sigma. In summary, as a result of the central limit theorem, letter 1D44B is normally distributed, that is, letter 1D44B, n, letter 1D707 letter 1D44B, letter 1D70 letter 1D45B square root. When the population standard deviation sigma is known, we use a normal distribution to calculate the error bound. Calculating the confidence interval to construct a confidence interval estimate for an unknown population mean, we need data from a random sample. The steps to construct and interpret the confidence interval are: calculate the sample mean letter 1D465 from the sample data. Remember, in this section, we already know the population standard deviation sigma. Find the z-score that corresponds to the confidence level. Calculate the error bound EBM. Construct the confidence interval. Write a sentence that interprets the estimate in the context of the situation in the problem. Explain what the confidence interval means in the words of the problem. We will first examine each step in more detail and then illustrate the process with some examples. Finding the z-score for the stated confidence level when we know the population standard deviation sigma. We use a standard normal distribution to calculate the error-bound EBM and construct the confidence interval. We need to find the value of z that puts an area equal to the confidence level in decimal form. In the middle of the standard normal distribution z, n0, 1. The confidence level, CL, is the area in the middle of the standard normal distribution. CL equals 1, alpha, so alpha is the area that is split equally between the two tails. Each of the tails contains an area equal to letter 1d6fc2. The z-score that has an area to the right of letter 1d6fc2 is denoted by letter 1d467 letter 1d6fc2. For example, when CL equals 0.95, alpha equals 0.5 and letter 1d6fc2 equals 0.25. We write letter 1d467 letter 1d6fc2 equals z0. 25. The area to the right of z0. 25 is 0.25 and the area to the left of z0. 25 is 1, 0, 25 equals 0. 975. Letter 1d467 letter 1d6fc2 equals z0. 25 equals 196, using a calculator, computer, or a standard normal probability table. Using the T83, 83 plus 84, 84 plus calculator in norm, 0. 975, 0, 1 equals 1. 96. Note: remember to use the area to the left of letter 1d467 letter 1d6fc2. In this chapter, the last two inputs in the invnorm command are 0, 1, because you are using a standard normal distribution z n0, 1. Writing the interpretation should clearly state the confidence level CL. Explain what population parameter is being estimated here, a population mean, and state the confidence interval, both endpoints. We estimate with % confidence that the true population mean, include the context of the problem, is between and include appropriate units. Example 8. Two supposed scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 scores is taken and gives a sample mean score of 68. Find a confidence interval estimate for the population mean exam score, the mean score on all exams. Problem: find a 90% confidence interval for the true population mean of statistics exam scores. Solution: you can use technology to calculate the confidence interval directly. The first solution is shown step by step. The second solution uses the T83, 83 plus, and 84 plus calculators. Figure 8. 3. The solution is shown step by step. The formula for a confidence interval for an unknown population mean, assuming we know the population standard deviation is letter 1d44b minus letter 1d44d letter 1d6fc, letter 1d70e letter 1d45b square root, less or equal to letter 1d707 less or equal to letter 1d44b plus letter 1d44d letter 1d6fc, letter 1d70e letter 1d45b square root, for a 90% confidence interval. Visualize an area of 0. 90 centered under the normal curve, see figure 8.3. The remaining area for the two tails of the normal distribution is then 0.10, which indicates that the area in the left tail is 1/2 of 0.10, which is 0. 5. The corresponding z-score that cuts off an area of 0. 5 in the left tail is 1. 645. In this example, we are given that the population standard deviation letter 1D70E equals 3. We are also given that the sample size n equals 36 and the sample mean letter 1D44B equals 68. Substituting these values in the confidence interval formula results in the following. Letter 1D44B minus letter 1D44D letter 1D6FC, letter 1D70E letter 1D45B square root, less or equal to letter 1D707 less or equal to letter 1D44B plus letter 1D44D letter 1D6FC, letter 1D70E letter 1D45B square root, 68 minus 1. 645, 336 square, less or equal to letter 1D707 less or equal to 68 plus 1. 645, 336 square, 68 minus 0. 8,225, less or equal to letter 1D707, less or equal to 68 plus 0. 82, 25, 67. 1,775, less or equal to letter 1D707, less or equal to 68. 8225, we estimate with 90% confidence that the true population mean exam score for all statistics students is between 67, 18, and 68. 82. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to 7, Z interval, press enter. Arrow to stats and press enter. Arrow down and enter 3 for sigma, 68 for letter 1D465, 36 for N, and 90 for C level. Arrow down to calculate and press enter. The confidence interval is to 3 decimal places, 67, 178, 68, 822. Explanation of 90% confidence level. 90% of all confidence intervals constructed in this way contain the true mean statistics exam score. For example, if we constructed 100 of these confidence intervals, we would expect 90 of them to contain the true population mean exam score. Try at 8. 2. Suppose average pizza delivery times are normally distributed with an unknown population mean and a population standard deviation of 6 minutes. A random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. Find a 90% confidence interval estimate for the population mean delivery time. Example 8. 3. The specific absorption rate SAR for a cell phone measures the amount of radio frequency, RF, energy absorbed by the user's body when using the handset. Every cell phone emits RF energy. Different phone models have different SAR measures. To receive certification from the Federal Communications Commission, FCC, for sale in the United States, the SAR level for a cell phone must be no more than 6 watts per kilogram. Table 8. 1 shows the highest SAR level for a random selection of cell phone models as measured by the FCC. SAR data for a sample of 30 cell phones 1, 11 1, 36 0, 74 1, 48 1 34 0 5 1, 43 1 18 0, 4 1 3 1 3 0, 867 1, 9 1, 26 0, 68 0, 455 1, 29 0, 51 1 41 0, 36 1 13 0, 82 0, 52 0 30, 78 1 61, 48 1 25 1, 39 1, 38. Table 8. 1 problem. Find a 98% confidence interval for the true population mean of the specific absorption rates SARs for cell phones. Assume that the population standard deviation is sigma equals 0. 337. Solution to find the confidence interval. Start by finding the point estimate, the sample mean. Letter 1D465 equals 1. 24 next, find the EBM. Because you are creating a 98% confidence interval, CL equals 0.98. This is a normal distribution curve. The point Z0. 1 is labeled at the right edge of the curve and the region to the right of this point is shaded. The area of this shaded region equals 0. 1. The unshaded area equals 0. 99. Figure 8. For you need to find Z0. 1 having the property that the area under the normal density curve to the right of Z0. 1 is 0. 1 and the area to the left is 0.99. Use your calculator, a computer, or a probability table for the standard normal distribution to find Z0. 1 equals 2,326. Letter 1D438, letter 1D435, letter 1D440 equals letter 1D4670. 0, 1. Letter 1D70, letter 1D45B square equals 2. 326, 0. 33,730 square equals 0. 1431. To find the 98% confidence interval, find letter 1D465 plus letter 1D438, letter 1D435, letter 1D440. Letter 1D465. EBM equals 124,01431 equals 0.8809. Letter 1D465. EBM equals 124,01431 equals 11671. We estimate with 98% confidence that the true SAR mean for the population of cell phones in the United States is between 0.8809 and 1.1671 watts per kilogram. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to 7. Z interval. Press enter. Arrow to stats and press enter. Arrow down and enter the following values. Sigma 0,337, letter 1D465, 124 N, 30 sea level 0. 98. Arrow down to calculate and press enter. The confidence interval is to 3 decimal places, 0,881, 1,167. Try at 8, 3 table 8. 2 shows a different random sampling of 20 cell phone models. Use this data to calculate a 93% confidence interval for the true mean SAR for cell phones certified for use in the United States. As previously, assume that the population standard deviation is sigma equals 0. 337. SAR data for a sample of 20 cell phones 1, 48 1, 53 080, 68 115 141, 36 124 0, 77 0, 57 0, 462 021, 36 0, 51 139 031, 30, 73 070, 869. Table 8. 2. Notice the difference in the confidence intervals calculated in example 8.3 and the following try it exercise. These intervals are different for several reasons. They were calculated from different samples, the samples were different sizes, and the intervals were calculated for different levels of confidence. Even though the intervals are different, they do not yield conflicting information. The effects of these kinds of changes are the subject of the next section in this chapter. Changing the confidence level or sample size, example 8. For problem, suppose we change the original problem in example 8.2 by using a 95% confidence level. Find a 95% confidence interval for the true population mean statistics exam score. We estimate with 95% confidence that the true population mean for all statistics exam scores is between 67, 2 and 68, 98. Explanation of 95% confidence level. 95% of all confidence intervals constructed in this way contain the true value of the population mean statistics exam score. Comparing the results. The 90% confidence interval is 67-18, 68, 82. The 95% confidence interval is 67-68, 98. The 95% confidence interval is wider. If you look at the graphs, because the area 0, 95 is larger than the area 0, 90, it makes sense that the 95% confidence interval is wider. To be more confident that the confidence interval actually does contain the true value of the population mean for all statistics exam scores, the confidence interval necessarily needs to be wider. Figure 8. 5. Summary. Effect of changing the confidence level, increasing the confidence level, increases the error bound, making the confidence interval wider. Decreasing the confidence level decreases the error bound, making the confidence interval narrower. Try at 8. 4. Refer back to the pizza delivery try-it exercise. The population standard deviation is 6 minutes, and the sample mean deliver time is 36 minutes. Use a sample size of 20. Find a 95% confidence interval estimate for the true mean pizza delivery time. Example 8. 5. Suppose we change the original problem in example 8. 2. To see what happens to the error bound if the sample size is changed. Problem: leave everything the same except the sample size. Use the original 90% confidence level. What happens to the error bound and the confidence interval if we increase the sample size and use n equals 100 instead of n equals 36? What happens if we decrease the sample size to n equals 25 instead of n equals 36? Letter 1D465 equals 68 EBM equals letter 1D467 letter 1D6FC2 letter 1D70 letter 1D45B square root sigma equals 3. The confidence level is 90%, CL equals 0. 90. Letter 1D467 letter 1D6FC2 equals Z0. 5 equals 1,645. Solution: if we increase the sample size n to 100, we decrease the error bound. When n equals 100, EBM equals letter 1D467 letter 1D6FC2, letter 1D70 letter 1D45B square root 1. 645. 3,100 square root equals 0.4935. Solution: if we decrease the sample size n to 25, we increase the error bound. When n equals 25, EBM equals letter 1D467 letter 1D6FC2, letter 1D70 letter 1D45B square root equals 1,645. 325 square root equals 0. 987. Summary. Effect of changing the sample size, increasing the sample size causes the error bound to decrease, making the confidence interval narrower. Decreasing the sample size causes the error bound to increase, making the confidence interval wider. Try at 8. 5. Refer back to the pizza delivery try-it exercise. The mean delivery time is 36 minutes, and the population standard deviation is 6 minutes. Assume the sample size is changed to 50 restaurants with the same sample mean. Find a 90% confidence interval estimate for the population mean delivery time. Working backwards to find the error bound or sample mean when we calculate a confidence interval, we find the sample mean, calculate the error bound, and use them to calculate the confidence interval. However, sometimes when we read statistical studies, the study may state the confidence interval only. If we know the confidence interval, we can work backwards to find both the error bound and the sample mean. Finding the error bound from the upper value for the interval, subtract the sample mean, or from the upper value for the interval, subtract the lower value. Then divide the difference by 2. Finding the sample mean, subtract the error bound from the upper value of the confidence interval, or average the upper and lower endpoints of the confidence interval. Notice that there are 2 methods to perform each calculation. You can choose the method that is easier to use with the information you know. Example 8. 6. Suppose we know that a confidence interval is 67, 18, 68, 82, and we want to find the error bound. We may know that the sample mean is 68, Or perhaps our source only gave the confidence interval and did not tell us the value of the sample mean. Calculate the error bound. If we know that the sample mean is 68, EBM equals 68, 82, 68 equals 0, 82. If we don't know the sample mean, EBM equals 68, 82 minus 67, 18.2 equals 0, 82. Calculate the sample mean. If we know the error bound, letter 1D465 equals 68, 82, 0. 82 equals 68 if we don't know the error bound. Letter 1D465 equals 6718 plus 68. 82 2 equals 68. Try it 8. 6. Suppose we know that a confidence interval is 4212, 4788. Find the error bound and the sample mean. Calculating the sample size in. If researchers desire a specific margin of error, then they can use the error-bound formula to calculate the required sample size. The error-bound formula for a population mean, when the population standard deviation is known, is EBM equals letter 1D467 letter 1D6FC2, letter 1D70 letter 1D45B square root. The formula for sample size is N equals Z letter 1D70 e to EBM2, found by solving the error-bound formula for N. In this formula, Z is letter 1D467 letter 1D6FC2, corresponding to the desired confidence level. A researcher planning a study who wants a specified confidence level and error-bound can use this formula to calculate the size of the sample needed for the study. Example 8. 7. The population standard deviation for the age of Foothill College students is 15 years. If we want to be 95% confident that the sample mean age is within 2 years of the true population mean age of Foothill College students, how many randomly selected Foothill College students must be surveyed? From the problem, we know that sigma equals 15 and EBM equals 2Z equals Z0. 25 equals 196 because the confidence level is 95%. N equals Z to letter 1D70 e to EBM, 2 equals 1. 96, 2, 15, 222 equals 216. 9 using the sample size equation. Use N equals 217. Always round the answer up to the next higher integer to ensure that the sample size is large enough. Therefore, 217 Foothill College students should be surveyed in order to be 95% confident that we are within 2 years of the true population mean age of Foothill College students. Try at 8. 7. The population standard deviation for the height of high school basketball players is 3 inches. If we want to be 95% confident that the sample mean height is within 1 inch of the true population mean height, how many randomly selected students must be surveyed? In practice, we rarely know the population standard deviation. In the past, when the sample size was large, this did not present a problem to statisticians. They used the sample standard deviation S as an estimate for sigma and proceeded as before to calculate a confidence interval with close enough results. However, statisticians ran into problems when the sample size was small. A small sample size caused inaccuracies in the confidence interval. William S. Gossett, 1876–1937, of the Guinness Brewery in Dublin, Ireland ran into this problem. His experiments with hops and barley produced very few samples. Just replacing sigma with S did not produce accurate results when he tried to calculate a confidence interval. He realized that he could not use a normal distribution for the calculation. He found that the actual distribution depends on the sample size. This problem led him to discover what is called the student's t-distribution. The name comes from the fact that Gossett wrote under the pen name student. Up until the mid-1970s, some statisticians used the normal distribution approximation for large sample sizes and used the student's t-distribution only for sample sizes of at most 30. With graphing calculators and computers, the practice now is to use the student's t-distribution, whenever S is used as an estimate for sigma. If you draw a simple random sample of size n from a population that has an approximately normal distribution with mean mu and unknown population, standard deviation sigma, and calculate the t-score t equals letter 1 d465, letter 1 d707, letter 1 d460, letter 1 d45b square root, then the t-scores follow a student's t-distribution with n, 1 degrees of freedom. The t-score has the same interpretation as the z-score. It measures how far letter 1d465 is from its mean mu. For each sample size n, there is a different student's t-distribution. The degrees of freedom, n1, come from the calculation of the sample standard deviation. This calculation requires n deviations, letter 1d465, letter 1d465 values. Because the sum of the deviations is 0, we can find the last deviation once we know the other n1 deviations. The other n1 deviations can change or vary freely. We call the number n1 the degrees of freedom, df. Properties of the student's t-distribution. The graph for the student's t-distribution is similar to the standard normal curve. The mean for the student's t-distribution is 0, and the distribution is symmetric about 0. The student's t-distribution has more probability in its tails than the standard normal distribution, because the spread of the t-distribution is greater than the spread of the standard normal. So the graph of the student's t-distribution will be thicker in the tails and shorter in the center than the graph of the standard normal distribution. The exact shape of the student's t-distribution depends on the degrees of freedom. As the degrees of freedom increases, the graph of students' t-distribution becomes more like the graph of the standard normal distribution. The underlying population of individual observations is assumed to be normally distributed with unknown population mean mu and unknown population standard deviation sigma. The size of the underlying population is generally not relevant unless it is very small. If it is bell-shaped, normal, then the assumption is met and doesn't need discussion. Random sampling is assumed, but that is a completely separate assumption from normality. Calculators and computers can easily calculate any student's t-probabilities. The T8383+ and 84+ have a TCDF function to find the probability for given values of t. The grammar for the TCDF command is TCDF, lower bound, upper bound, degrees of freedom. However, for confidence intervals, we need to use inverse probability to find the value of t when we know the probability. For the T84+, you can use the invt command on the distribution menu. The invt command works similarly to the invnorm. The invt command requires two inputs, invt, area to the left, degrees of freedom. The output is the t-score that corresponds to the area we specified. The T83 and 83+ do not have the invt command. The T89 has an inverse t command. A probability table for the student's t-distribution can also be used. The table gives t-scores that correspond to the confidence level column and degrees of freedom row. The T86 does not have an invt program or command, so if you are using that calculator, you need to use a probability table for the student's t-distribution. When using a t-table, note that some tables are formatted to show the confidence level in the column headings, while the column headings in some tables may show only corresponding area in one or both tails. A student's t-table, see Appendix H tables, gives t-scores given the degrees of freedom and the right-tailed probability. The table is very limited. Calculators and computers can easily calculate any student's t-probabilities. The notation for the student's t-distribution, using t as the random variable, is t-tdf, where df equals n1. For example, if we have a sample of size n equals 20 items, then we calculate the degrees of freedom as df equals n, 1 equals 21 equals 19, and we write the distribution as t19. If the population standard deviation is not known, The error bound for a population mean is letter 1D438, letter 1D435, letter 1D440 equals letter 1D461, letter 1D6FC2, letter 1D460, letter 1D45B square root. Letter 1D461, letter 1D70E2 is the t-score with area to the right equal to letter 1D6FC2. Use df equals n 1 degrees of freedom, and s equals sample standard deviation. The format for the confidence interval is letter 1D465 minus letter 1D438, letter 1D435, letter 1D440, letter 1D465 plus letter 1D438, letter 1D435, letter 1D440. Using the T83, 83 plus 84, 84 plus calculator to calculate the confidence interval directly, press Stat. Arrow over to Tests. Arrow down to 8. T-interval and press Enter, or just press 8. Example 8. 8 problems. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population, assumed normal, from which you took the data. The solution is shown step by step and by using the T83, 83 plus or 84 plus calculators. 8694796883 73929687 11 4103 54 81 55 69 solution. The first solution is step by step. The second solution uses the T83 plus and T84 calculators. To find the confidence interval, you need the sample mean, letter 1D465, and the EBM. Letter 1D465 equals 82267, S equals 1. 6722, N equals 15, DF equals 15. 1 equals 14 CL, so alpha equals 1. CL equals 1, 0, 95 equals 0. 5 letter 1D6FC2 equals 0, 25 letter 1D461 letter 1D6FC2 equals letter 1D4610. 25 the area to the right of T0. 25 is 0, 25, and the area to the left of T0. 25 is 1, 0, 25 equals 0. 975 letter 1D461 letter 1D6FC2 equals letter 1D4610. 0, 25 equals 2. 14 using INV-T. 97,514 on the T84 plus calculator. Letter 1D438, letter 1D435, letter 1D440 equals letter 1D461, letter 1D6FC2. Letter 1D460, letter 1D45B square root. Letter 1D438, letter 1D435, letter 1D440 equals 2. 14, 1. 672,215 square root equals 0. 924 letter 1D465, EBM equals 82267, 0. 9240 equals 73 letter 1D465 plus EBM equals 82267 plus 0. 9240 equals 9. 15. The 95% confidence interval is 7. 30, 915. We estimate with 95% confidence that the true population mean sensory rate is between 730 and 915. Solution using the T83, 83 plus, 84, 84 plus calculator. Press Stat and arrow over to Tests. Arrow down to 8, T-interval and press Enter, or you can just press 8. Arrow to Data and press Enter. Arrow down to List and enter the list name where you put the data. There should be a 1 after freak. Arrow down to Sea Level and enter 0. 95 arrow down to Calculate and press Enter. The 95% confidence interval is 73006, 9. 1527. Note, when calculating the error bound, a probability table for the student's t-distribution can also be used to find the value of t. The table gives t-scores that correspond to the confidence level column and degrees of freedom row. The t-score is found where the row and column intersect in the table. Try it 8. 8. You do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population assumed normal from which you took the data. 82, 91, 77, 86, 69, 11.2, 10.1, 9, 9, 8, 9, 9.2, 7.5, 10.5. Example 8. 9. Problem. The Human Toxome Project (HTP) is working to understand the scope of industrial pollution in the human body. Industrial chemicals may enter the body through pollution or as ingredients in consumer products. The scientists at HTP tested cord blood samples for 20 newborn infants in the United States. The cord blood of the in utero/newborn group was tested for 430 industrial compounds, pollutants, and other chemicals, including chemicals linked to brain and nervous system toxicity, immune system toxicity, and reproductive toxicity and fertility problems. There are health concerns about the effects of some chemicals on the brain and nervous system. Table 8. 3 shows how many of the targeted chemicals were found in each infant's cord blood. 79, 145, 147, 160, 116, 100, 159, 151, 156, 126, 137, 83, 156, 94, 121, 144, 123, 114, 139, 99. Table 8. 3. Use this sample data to construct a 90% confidence interval for the mean number of targeted industrial chemicals to be found in an infant's blood. Solution from the sample. You can calculate letter 1d465 equals 127, 45 and S equals 25, 965. There are 20 infants in the sample, so N equals 20 and DF equals 20, 1 equals 19. You are asked to calculate a 90% confidence interval. CL equals 0. 90, so alpha equals 1, CL equals 1, 0, 90 equals 0. 10 letter 1d6fc2 equals 0. 5 by definition, the area to the right of T0. 5 is 0. 5 and so the area to the left of T0. 5 is 1, 0, 5 equals 0, 95. Use a table, calculator, or computer to find that T0. 5 equals 1, 729. Letter 1d438, letter 1d435, letter 1d440 equals letter 1d461, letter 1d6fc, 2 letter 1d460, letter 1d45b square root equals 1. 729, 25. 96,520 square root, approximately 10. 38 letter 1d465, EBM equals 127, 45, 10. 38 equals 117. 412 letter 1d465 plus EBM equals 127, 45 plus 10. 38 equals 137. 488. We estimate with 90% confidence that the mean number of all targeted industrial chemicals found in cord blood in the United States is between 117, 412 and 137, 488. Solution using the T83, 83 plus 84, 84 plus calculator. Enter the data as a list. Press Stat and arrow over to Tests. Arrow down to 8, T interval and press Enter, or you can just press 8. Arrow to Data and press Enter. Arrow down to List and enter the list name where you put the data. Arrow down to Freak and enter 1. Arrow down to Sea Level and enter 0. 90. Arrow down to Calculate and press Enter. The 90% confidence interval is 117.41, 137, 49. Try it 8. 9. A random sample of statistics students were asked to estimate the total number of hours they spend watching television in an average week. The responses are recorded in Table 8. 4. Use this sample data to construct a 98% confidence interval for the mean number of hours statistics students will spend watching television in 1 week. 03 129 510 110 4 14 2 4 4 5 Table 8. 4. During an election year, we see articles in the newspaper that state confidence intervals in terms of proportions or percentages. For example, a poll for a particular candidate running for president might show that the candidate has 40% of the vote within 3 percentage points, if the sample is large enough. Often, election polls are calculated with 95% confidence. So, the pollsters would be 95% confident that the true proportion of voters who favored the candidate would be between 0.37 and 0.43, 0.40, 0.30, 40 plus 0.3. Investors in the stock market are interested in the true proportion of stocks that go up and down each week. Businesses that sell personal computers are interested in the proportion of households in the United States that own personal computers. Confidence intervals can be calculated for the true proportion of stocks that go up or down each week, and for the true proportion of households in the United States that own personal computers. The procedure to find the confidence interval, the sample size, the error bound, and the confidence level for a proportion is similar to that for the population mean, but the formulas are different. How do you know you are dealing with a proportion problem? First, the underlying distribution is a binomial distribution. There is no mention of a mean or average. If x is a binomial random variable, then xb, n, p, where n is the number of trials and p is the probability of a success. To form a proportion, take x, the random variable for the number of successes, and divide it by n, the number of trials or the sample size. The random variable letter 1d45d, read p prime. Is that proportion? Letter 1d443 equals letter 1d44b letter 1d45b. Sometimes the random variable is denoted as letter 1d443 letter 2c6, read p hat. When n is large and p is not close to 0 or 1, we can use the normal distribution to approximate the binomial. Letter 1d44b tilde letter 1d441, letter 1d45b letter 1d45d, letter 1d45b letter 1d45d letter 1d45e square. If we divide the random variable, the mean, and the standard deviation by n, we get a normal distribution of proportions with letter 1d45d, called the estimated proportion, as the random variable. Recall that a proportion as the number of successes divided by n, letter 1d44b letter 1d45b, equals letter 1d443 tilde letter 1d441, letter 1d45b letter 1d45d letter 1d45b. Letter 1d45b letter 1d45d letter 1d45e square root letter 1d45b. Using algebra to simplify. Letter 1d45b letter 1d45d letter 1d45e square root letter 1d45b equals letter 1d45d letter 1d45e letter 1d45b square letter 1d45d follows a normal distribution for proportions. Letter 1d44b letter 1d45b equals letter 1d443 tilde letter 1d441, letter 1d45d, letter 1d45d letter 1d45e letter 1d45b square. The confidence interval has the form letter 1d45d, EBP, letter 1d45d plus EBP. EBP is error bound for the proportion. Letter 1d45d equals letter 1d465 letter 1d45b, letter 1d45d equals the estimated proportion of successes. Letter 1d45d is a point estimate for p, the true proportion. X equals the number of successes, n equals the size of the sample, the error bound for a proportion, is letter 1d438, letter 1d435, letter 1d443 equals letter 1d467, letter 1d6fc2. Letter 1d45d, letter 1d45e, letter 1d45b square, where letter 1d45e equals 1, letter 1d45d, This formula is similar to the error-bound formula for a mean, except that the appropriate standard deviation is different. For a mean, when the population standard deviation is known, the appropriate standard deviation that we use is letter 1D70 letter 1D45B square root. For a proportion, the appropriate standard deviation is letter 1D45D letter 1D45E letter 1D45B square. However, in the error-bound formula, we use letter 1D45D letter 1D45E letter 1D45B square as the standard deviation, instead of letter 1D45D letter 1D45E letter 1D45B square. In the error-bound formula, the sample proportions letter 1D45D and letter 1D45E are estimates of the unknown population proportions P and Q. The estimated proportions letter 1D45D and letter 1D45E are used because P and Q are not known. The sample proportions letter 1D45D and letter 1D45E are calculated from the data. Letter 1D45D is the estimated proportion of successes, and letter 1D45E is the estimated proportion of failures. The confidence interval can be used only if the number of successes NP and the number of failures NQ are both greater than 5. Note for the normal distribution of proportions, the z-score formula is as follows. If letter 1D443 tilde letter 1D441, letter 1D45D, letter 1D45D, letter 1D45E, letter 1D45B square, then the z-score formula is letter 1D467 equals letter 1D45D minus letter 1D45D, letter 1D45D, letter 1D45E, letter 1D45B square root. Example 8. 10 problems suppose that a market research firm is hired to estimate the percent of adults living in a large city who have smartphones. 500 randomly selected adult residents in this city are surveyed to determine whether they have smartphones. Of the 500 people surveyed, 421 responded yes, they own smartphones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of this city who have smartphones. Solution. The first solution is step-by-step. The second solution uses a function of the T83, 83 plus, or 84 calculators. Let x equals the number of people in the sample who have cell phones. X is binomial. Letter 1D44B tilde letter 1D435, 500, 421,500. To calculate the confidence interval, you must find letter 1D45D, letter 1D45E, and EBP. N equals 500, x equals the number of successes, equals 421, letter 1D45D equals letter 1D465, letter 1D45B equals 421,500 equals 0. 842, letter 1D45D equals 0. 842 is the sample proportion. This is the point estimate of the population proportion. Letter 1D45E equals 1 minus letter 1D45D equals 1 minus 0. 842 equals 0. 158 since CL equals 0. 95, then alpha equals 1, CL equals 1, 0. 95 equals 0. 5, letter 1D6FC2 equals 0. 25. Then letter 1D467, letter 1D6FC2 equals letter 1D4670. 0. 25 equals 1. 96 use the T83, 83 plus, or 84 plus calculator command in norm, 0. 97,501 to find Z0. 25. Remember that the area to the right of Z0. 25 is 0.25 and the area to the left of Z0. 25 is 0. 975. This can also be found using appropriate commands on other calculators, using a computer, or using a standard normal probability table. Letter 1D438, letter 1D435, letter 1D443 equals letter 1D467, letter 1D6FC, 2 letter 1D45D, letter 1D45E, letter 1d45b square equals 1. 96, 0. 842, 0. 158, 500 square equals 0. 32, letter 1d45d, letter 1d438, letter 1d435, letter 1d443 equals 0. 842, 0. 0, 32 equals 0. 81, letter 1d45d plus letter 1d438, letter 1d435, letter 1d443 equals 0. 842 plus 0. 0, 32 equals 0. 874, the confidence interval for the true binomial population proportion is letter 1d45d, letter 1d438, letter 1d435, letter 1d443. Letter 1d45d plus EBP equals 0. 8100. 874. Interpretation. We estimate with 95% confidence that between 81% and 4% of all adult residents of this city have smartphones. Explanation of 95% confidence level. 95% of the confidence intervals constructed in this way would contain the true value for the population proportion of all adult residents of this city who have smartphones. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to A, 1 prop zint, press enter. Arrow down to X and enter 421. Arrow down to N and enter 500. Arrow down to C level and enter 95. Arrow down to calculate and press enter. The confidence interval is 080 1003, 080 7397. Try at 8. 10. Suppose 250 randomly selected people are surveyed to determine if they own a tablet. Of the 250 surveyed, 98 reported owning a tablet. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of people who own tablets. Example 8. 11. Problem for a class project. A political science student at a large university wants to estimate the percent of students who are registered voters. He surveys 500 students and finds that 300 are registered voters. Compute a 90% confidence interval for the true percent of students who are registered voters and interpret the confidence interval. Solution. The first solution is step-by-step. The second solution uses a function of the T83, 83 plus, or 84 calculators. X equals 300 and N equals 500. Letter 1d45d equals letter 1d465, letter 1d45b equals 300,500 equals 0. 600. Letter 1d45e equals 1 minus letter 1d45d equals 1 minus 0. 600 equals 0. 400 since CL equals 0. 90, then alpha equals 1, CL equals 1, 0, 90 equals 0. 10, letter 1d6fc2 equals 0. 5, letter 1d467, letter 1d6fc2 equals z0. 5 equals 1. 645. Use the T83, 83 plus, or 84 plus calculator command in norm 0. 9501 to find z0. 5. Remember that the area to the right of z0, 5 is 0. 5 and the area to the left of z0, 5 is 0, 95. This can also be found using appropriate commands on other calculators, using a computer, or using a standard normal probability table. Letter 1d438, letter 1d435, letter 1d443 equals letter 1d467, letter 1d6fc, 2 letter 1d45d, letter 1d45e, letter 1d45b square equals 1. 645, 0. 60, 0. 40, 500 square equals 0. 36. Letter 1d45d, letter 1d438, letter 1d435, letter 1d443 equals 0. 60 minus 0. 0, 36 equals 0. 564 letter 1D45D plus letter 1D438 letter 1D435 letter 1D443 equals 0. 60 plus 0. 036 equals 0. 636. The confidence interval for the true binomial population proportion is letter 1D45D EBP. Letter 1D45D plus EBP equals 0. 5640. 636. Interpretation. We estimate with 90% confidence that the true percent of all students that are registered voters is between 56, 4% and 63, 6%. Alternate wording. We estimate with 90% confidence that between 56, 4% and 63, 6% of all students are registered voters. Explanation of 90% confidence level. 90% of all confidence intervals constructed in this way contain the true value for the population percent of students that are registered voters. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to A, 1 prop zint, press enter. Arrow down to X and enter 300. Arrow down to N and enter 500. Arrow down to C level and enter 0. 90. Arrow down to calculate and press enter. The confidence interval is 0 564, 0 636. Try at 8. 11. A student polls their school to see if students in the school district are for or against the new legislation regarding school uniforms. They survey 600 students and finds that 480 are against the new legislation. A. Compute a 90% confidence interval for the true percent of students who are against the new legislation, and interpret the confidence interval. B. In a sample of 300 students, 68% said they own an iPod and a smartphone. Compute a 97% confidence interval for the true percent of students who own an iPod and a smartphone. Plus 4. Confidence interval for P. There is a certain amount of error introduced into the process of calculating a confidence interval for a proportion. Because we do not know the true proportion for the population, we are forced to use point estimates to calculate the appropriate standard deviation of the sampling distribution. Studies have shown that the resulting estimation of the standard deviation can be flawed. Fortunately, there is a simple adjustment that allows us to produce more accurate confidence intervals. We simply pretend that we have 4 additional observations. 2 of these observations are successes and 2 are failures. The new sample size, then, is n plus 4, and the new count of successes is x plus 2. Computer studies have demonstrated the effectiveness of this method. It should be used when the confidence level desired is at least 90% and the sample size is at least 10. Example 8. 12 problem, a random sample of 25 statistics students was asked, have you smoked a cigarette in the past week? 6 students reported smoking within the past week. Use the plus 4 method to find a 95% confidence interval for the true proportion of statistics students who smoke. Solution: 6 students out of 25 reported smoking within the past week, so x equals 6 and n equals 25. Because we are using the plus 4 method, we will use x equals 6 plus 2 equals 8, and n equals 25 plus 4 equals 29. Letter 1D45D equals letter 1D465 letter 1D45B equals 829 approximately 0. 276 letter 1D45E equals 1 letter 1D45D equals 1 0. 276 equals 0. 724 since CL equals 0. 95, we know alpha equals 1. 0.95 equals 0.5 and letter 1D6FC2 equals 0.25. Z0. 0.25 equals 1. 96, letter 1D438, letter 1D435, letter 1D443 equals. Letter 1D467, letter 1D6FC2. Letter 1D45D, letter 1D45E, letter 1D45B square equals 1. 96, 0. 276, 0. 724.29 square approximately 0. 163 letter 1d45d, EBP equals 0, 276 0. 163 equals 0, 113 letter 1d45d, plus EBP equals 0, 276 plus 0, 163 equals 0. 439. We are 95% confident that the true proportion of all statistics students who smoke cigarettes is between 0,113 and 0,439. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to A, 1 prop zint. Press enter. Reminder: remember that the +4 method assume an additional 4 trials, 2 successes and 2 failures. You do not need to change the process for calculating the confidence interval. Simply update the values of X and N to reflect these additional trials. Arrow down to X and enter 8. Arrow down to N and enter 29. Arrow down to C level and enter 0. 95. Arrow down to calculate and press enter. The confidence interval is 0,113, 0,439. Try at 8. 12 out of a random sample of 65 first-year students at State University, 31 students have declared a major. Use the +4 method to find a 96% confidence interval for the true proportion of first-year students at State University who have declared a major. Example 8. 13 problem: a marketing research firm conducted a survey regarding the potential purchase of electric vehicles among adults aged 18-29. In a group of 50 adults aged 18-29, 13 of them reported they would consider the purchase of an electric vehicle. Use the +4 method to find a 90% confidence interval for the true proportion of adults aged 18-29 who would consider the purchase of an electric vehicle. Solution using +4. We have X equals 13 plus 2 equals 15 and N equals 50 plus 4 equals 54. Letter 1d45d equals 1554 approximately 0. 278 letter 1d45e equals 1 letter 1d45d equals 1 minus 0. 241 equals 0. 722 since CL equals 0. 90 we know alpha equals 1, 090 equals 010, and letter 1d6fc2 equals 05. Z0. 645, letter 1d438, letter 1d435, letter 1d443 equals letter 1d467, letter 1d6fc2. Letter 1d45d, letter 1d45e, letter 1d45b square equals 1. 645, 0. 278, 0. 722 54 square approximately 0. 100 letter 1d45d, EBP equals 0. 278, 0. 100 equals 0. 178 letter 1d45d plus EBP equals 0. 278 plus 0, 100 equals 0. 378, we are 90% confident that between 17, 8% and 37, 8% of adults aged 18-29 would consider the purchase of an electric vehicle. Solution using the T83, 83 plus 84, 84 plus calculator. Press stat and arrow over to tests. Arrow down to A, 1 prop zint. Press enter. Arrow down to X and enter 15. Arrow down to N and enter 54. Arrow down to C level and enter 0. 90. Arrow down to calculate and press enter. The confidence interval is 0,178, 0,378. Try at 8. 13 the survey referenced in example 8. 13 talked to adults aged 18-29 in smaller focus groups, but also interviewed additional individuals over the phone. When the study was complete, 588 adults aged 18-29 had answered the question about their potential purchase of an electric vehicle, with 159 saying that they would consider such a purchase. Use the +4 method to find a 90% confidence interval for the true proportion of adults aged 18-29 who would consider the purchase of an electric vehicle based on this larger sample. Compare the results to those in example 813. Calculating the sample size n. If researchers desire a specific margin of error, then they can use the error-bound formula to calculate the required sample size. The error-bound formula for a population proportion is letter 1d438, letter 1d435, letter 1d443 equals letter 1d467, letter 1d6fc2, letter 1d45d, letter 1d45e, letter 1d45b square. Solving for n gives you an equation for the sample size. Letter 1d45b equals letter 1d467, letter 1d6fc, 2, letter 1d45d, letter 1d438, letter 1d435, letter 1d443, 2. Example 8. 14 problem. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 plus who use text messaging on their cell phones? Solution from the problem: we know that EBP equals 0, 3% equals 0, 3, and letter 1d467, letter 1d6fc, 2z0, 5 equals 1. 645 because the confidence level is 90%. However, in order to find n, we need to know the estimated sample proportion p. Remember that q equals 1p, but we do not know p yet. Since we multiply p and q together, we make them both equal to 0, 5 because peak equals 0, 5, 0, 5 equals 0, 25 results in the largest possible product. Try other products. 0, 6, 0, 4 equals 0, 24, 0, 3, 0, 7 equals 0, 21, 0, 2, 0, 8 equals 0, 16, and so on. The largest possible product gives us the largest n. This gives us a large enough sample so that we can be 90% confident that we are within 3 percentage points of the true population proportion. To calculate the sample size n, use the formula and make the substitutions. Letter 1d45b equals letter 1d467 to letter 1d45d, letter 1d45e, letter 1d438, letter 1d435, letter 1d4432, gives letter 1d45b equals 1. 6452 0, 5, 0, 5, 0, 0, 32 equals 751. 7. Round the answer to the next higher value. The sample size should be 752 cell phone customers aged 50 plus in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of all customers aged 50 plus who use text messaging on their cell phones. Try it 8. 14. Suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. How many customers should the company survey in order to be 90% confident that the estimated proportion is within 5 percentage points of the true population proportion of customers who click on ads on their smartphones? Stats Lab. Confidence interval, home costs. Class time, names, student learning outcomes. The student will calculate the 90% confidence interval for the mean cost of a home in the area in which this school is located. The student will interpret confidence intervals. The student will determine the effects of changing conditions on the confidence interval. Collect the data. Check the real estate section in your local newspaper. Record the sale prices for 35 randomly selected homes recently listed in the county. Note: many newspapers list them only 1 day per week. Also, we will assume that homes come up for sale randomly. Complete the table. Table 8.5. Describe the data. Compute the following. Letter 1D465 equals letter 1D460, letter 1D465 equals n equals. In words, define the random variable letter 1D44b. State the estimated distribution to use. Use both words and symbols. Find the confidence interval. Calculate the confidence interval and the error bound. Confidence interval. Error bound. How much area is in both tails combined? Alpha equals. How much area is in each tail? Letter 1D6FC2. Equals. Fill in the blanks on the graph with the area in each section. Then, fill in the number line with the upper and lower limits of the confidence interval and the sample mean. Normal distribution curve with two vertical upward lines from the x-axis to the curve. The confidence interval is between these two lines. The residual areas are on either side. Figure 8. 6. Some students think that a 90% confidence interval contains 90% of the data. Use the list of data on the first page and count how many of the data values lie within the confidence interval. What percent is this? Is this percent close to 90%? Explain why this percent should or should not be close to 90%. Describe the confidence interval. In 2 to 3 complete sentences, explain what a confidence interval means in general, as if you were talking to someone who has not taken statistics. In 1 to 2 complete sentences, explain what this confidence interval means for this particular study. Use the data to construct confidence intervals. Using the given information, construct a confidence interval for each confidence level given. Confidence level EBM/error, bound confidence interval. 50%, 80%, 95%, 99%. Table 8.6. What happens to the EBM as the confidence level increases? Does the width of the confidence interval increase or decrease? Explain why this happens. Stats Lab. Confidence interval, place of birth. Class time, names, student learning outcomes. The student will calculate the 90% confidence interval, the proportion of students in this school who were born in this state. The student will interpret confidence intervals. The student will determine the effects of changing conditions on the confidence interval. Collect the data. Survey the students in your class, asking them if they were born in this state. Let x equals the number that were born in this state. N equals. X equals. In words, define the random variable p. State the estimated distribution to use. Find the confidence interval and error bound. Calculate the confidence interval and the error bound. Confidence interval. Error bound. How much area is in both tails combined? Alpha equals. How much area is in each tail? Letter 1D6FC2. Equals. Fill in the blanks on the graph with the area in each section. Then, fill in the number line with the upper and lower limits of the confidence interval and the sample proportion. Normal distribution curve with two vertical upward lines from the x-axis to the curve. The confidence interval is between these two lines. The residual areas are on either side. Figure 8. 7. Describe the confidence interval. In 2 to 3 complete sentences, explain what a confidence interval means in general, as though you were talking to someone who has not taken statistics. In 1 to 2 complete sentences, explain what this confidence interval means for this particular study. Construct a confidence interval for each confidence level given. Confidence level EBP/error, bound confidence interval. 50%, 80%, 95%, 99%. Table 8.7. What happens to the EBP as the confidence level increases? Does the width of the confidence interval increase or decrease? Explain why this happens. Stats Lab. Confidence interval, women's heights. Class time, names, student learning outcomes. The student will calculate a 90% confidence interval using the given data. The student will determine the relationship between the confidence level and the percentage of constructed intervals that contain the population mean. Given 59, 471, 669, 365, 62, 966, 561, 755, 2. 67, 567, 263, 862, 963, 063, 968, 765. 5. 61, 969, 658, 763, 461, 860, 669, 860, 0. 64, 966, 166, 860, 665. 663, 861, 359, 2. 64, 159, 364, 962, 463, 560, 963, 366, 3. 61, 564, 362, 960, 663, 858, 864, 965, 7. 62, 570, 962, 963, 162, 258, 764. 766, 0. 60, 564, 765, 460, 265, 064, 161, 165, 3. 64, 659, 261, 462. 63, 561, 465, 562, 3. 65, 564, 758, 866, 164, 966, 957, 969. 8. 58, 563, 469, 265, 962, 260, 058, 162, 5. 62, 459, 166, 461, 260. 458, 766, 767, 5. 63, 256, 667, 762, 5. Table 8. 8 heights of 100 women in inches. Table 8. 8 lists the heights of 100 women. Use a random number generator to select 10 data values randomly. Calculate the sample mean and the sample standard deviation. Assume that the population standard deviation is known to be 33 inches. With these values, construct a 90% confidence interval for your sample of 10 values. Write the confidence interval you obtained in the first space of Table 8. 9. Now write your confidence interval on the board. As others in the class write their confidence intervals on the board, copy them into Table 8. 9. Table 8. 9 90% confidence intervals. Discussion questions. The actual population mean for the 100 heights given Table 8. 8 is mu equals 63. 4. Using the class listing of confidence intervals, count how many of them contain the population mean mu, i.e., for how many intervals does the value of mu lie between the endpoints of the confidence interval. Divide this number by the total number of confidence intervals generated by the class to determine the percent of confidence intervals that contains the mean mu. Write this percent here. Is the percent of confidence intervals that contain the population mean mu close to 90%? Suppose we had generated 100 confidence intervals. What do you think would happen to the percent of confidence intervals that contain the population mean? When we construct a 90% confidence interval, we say that we are 90% confident that the true population mean lies within the confidence interval. Using complete sentences, explain what we mean by this phrase. Some students think that a 90% confidence interval contains 90% of the data. Use the list of data given, the heights of women, and count how many of the data values lie within the confidence interval that you generated based on that data. How many of the 100 data values lie within your confidence interval? What percent is this? Is this percent close to 90%? Explain why it does not make sense to count data values that lie in a confidence interval. Think about the random variable that is being used in the problem. Suppose you obtain the heights of 10 women and calculated a confidence interval from this information. Without knowing the population mean mu, would you have any way of knowing for certain if your interval actually contained the value of mu? Explain.